Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of quadratic domain and range, specifically how we can find those when using graphs, and we'll do it in 5 minutes or less. So when we're talking about quadratic functions, remember that the standard form of quadratics is going to be ax squared plus bx plus c. We know that it's a quadratic because we have the highest degree or the highest exponent of 2, so we're going to square something. And when we see that, some form of that, we are going to see this shape on a graph, a parabola. Now sometimes we'll get a restricted domain and range, so it might not be a full parabola. Sometimes it faces up, but that's what we're looking at here. Now the domain and range are those two terms. We've seen those before in the linear function. So sometimes we'll see a line on a graph and we'll need to find the domain and range of that line. So we also need to find the domain and range of this parabola if it's a quadratic function. So the domain is still going to be all possible independent variable values. So those are our x values. Now the range is all possible dependent variable values. In this case it's going to be the y, but sometimes if it's a function it might be f of x. It might be g of x. This one changes quite a bit depending on what type of problem you have. But the range is always going to be the dependent variable values. It's going to be the vertical line on the axis. So when we are trying to find the domain and range of this particular graph here, let's just take a look at the domain first. And even though this parabola doesn't necessarily obviously show everything, we can take a look. Remember our x values. We want to see how far left and right it's going to go. Okay? And you see here that it's expanding out. It's going down, but it's also moving left and moving right a little bit. Now, this particular graph goes on forever. So we have to assume that it's going to continue to expand forever. So we're going to say it two different ways. All real numbers, because it's really going to be everything. Or if we wanted to show it mathematically, we could say it's going to be greater than negative infinity and less than positive infinity. But it's going to be all real numbers, because that domain, the x is going to spread forever. Now the range definitely has a limit. So you notice it goes right up there to that 3, hits it, and moves down. So what we'll say is that y is going to be less than or equal to 3, because that's its limit. That's the top of the parabola, and then it moves down. So that would be the domain and range of just a traditional parabola. Let's look at one that has a restricted domain and range. Sometimes you'll see part of a parabola here, and you notice that it ends right there. So if I'm looking at my x values, right, I've got a half, got 1, got 1.5 right there. So it looks like it's a 1 right there. Now what we don't know is whether it's an open circle or a closed circle. So let's assume for our purposes here it is a closed circle, right? So closed means you can include that. So that it's going to be less than, so let's look at our domain here. So x is going to be less than or equal to if it's closed. If it were open, right, then we would do just simply a less than, because we couldn't include that. But let's say it's less than or equal to 1. Because once again, the x is not going to be greater than 1. And even though it's barely moving over as we go up on this graph, it is going up, 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 but it's also moving to the left a little bit. So it's going to continue for infinity, slightly creep over to the left, and include all negative values. So that would be our domain. Now our range is kind of interesting. So it moves up right here to about like a 3.5, but we're not really looking at this maximum value right here. What we're looking at is what is the bottom value. So the lowest value is going to be that 2. So it picks up that 2, so it's going to be greater than or equal to 2. And even though it's not going to be greater than or equal to 2 on this upward arc over here to the right, it will, on the left, it'll pick up all of these. And so that's how you find the domain and range.